Hi, in this third section, we are going to discuss about the use of t-test to hypothesizing concerning the population mean. But in this case, the standard deviation of the population will be unknown. Let's go directly to the problem set. Note that here we use the same problem set as the previous one, but the information concerning the population standard deviation is wiped out. So we have the information only concerning the population's mean, which is realistic because normally people only have a rough estimation concerning the population's mean without ever considering population standard deviation. Let's restate the problem set again. A study states that population's mean height of Indonesian citizens equals to 165 centimeters. A consultancy firm would like to test the claim by studying a sample of 100 respondents. From the sample's analysis, the value of sample's mean height is equal to 170 centimeters, and the sample's standard deviation equals to 30 centimeters. Determine whether there is evidence at the level of 0.05 significance that the population's mean height value is different from the previous claim of 165 centimeters. Let's apply the 6 steps approach. First, we state the null hypothesis. The mean height value of Indonesian citizens equal to 165 centimeter, and the alternative hypothesis will be the mean height of Indonesian citizen is not equal to 165 centimeter. We go to the second step. We choose the level significance of alpha equal to 0.05. The sample size is 106 respondents. And then we go to the third step, determining the appropriate test statistics and the sampling distribution. Because we only know the information concerning the population's mean without knowing the information concerning the population standard deviation, thus we have to use the t-step test statistics. Let's go to the fourth step, determining the critical values that will divide the rejection and the non-rejection regions. Note, at the problem set, we have the information of the level of significance that is picked as 0.05, and the number of respondents that we chosen is 100 respondents. Thus, the value of degree of freedom will be n-1, which is 100 respondents minus 1, which is 99. How to define the critical values? Since we have a two-tailed case, then the error term of 0.05 will be divided evenly to the both direction, both to the right side and the left side. Then the 0.05 error term will be divided by 2. Then at the right side we state the error as 0.025 equally with the left side. And by using the t table, we have two informations, the alpha value and also the degree of freedom value. Then we simply pick the right or the appropriate t value for determining the critical value of the t. So here we have the degrees of freedom of value 99. And the upside we choose 0.025, and then we have the value of 1.9842, and this value will be then defined as the critical value. Both at the right side, the critical value will be defined as plus 1.9842, and then at the left side, the critical value will be minus 1.9842. Since it's a normal distribution, then the value will be symmetrical. Okay, let's go to the fifth step. Collect the sample data, organize the results, and compute the value of the test statistics. Now, the formula that we're having is t-statistics. T-stats is used especially when we don't have any information concerning the population standard deviation. Let's just apply the formula to have the t-stats value. The x bar, which is the population's mean, is equals to 170 centimeter minus the mu for the population's mean, which is stated as 165 centimeter, divided by S, which is the samples of standard deviations, equals to 30 centimeter divided by square root of N, number of respondents, which is the square root of 100. After applying this number to the t-stat formula, we have the value of t-stat of 1.667. Let's go to the final stage. State the statistical decisions and the managerial conclusion. Yeah. Since we have calculated that t-stats of our sample equals to 1.667, and this value lies within the region of rejections, so here we know that the critical value at the left side is minus 0.1. Here we know that the critical value at the left side is minus 1.9842, and the critical value of the at the right side is equals to 1.9842, and the t-stats of the samples lies within the region of rejections. Then the conclusion we can take is that the null hypothesis, which states that population's mean value of height of Indonesian citizen equals to 165 centimeter, cannot be rejected. This is the end of section 3.